the mean value theorem. Okay, so the first thing before I show you the mean value theorem, I have to show you what we call Rolle's theorem. Okay, so let me give you the actual theorem, and I'm going to explain to you with a little picture. Okay, so let f be a function such that three things. One, f is continuous on the interval AB closed. Second, f is differentiable on AB open. And three, f of A equals f of B. Then there is a number C in AB such that f prime of C is equal to 0.
So it just means C is a constant?
Sorry, C is a what do you mean C is a constant?
F prime of C. It means that C is a constant.
C is a number, yeah. You think, oh, because f prime of C is 0, it means the function is flat. That's what you're saying?
Yeah.
No, it's at that point, at that value, at C, the function has its horizontal slope.
Okay.
Okay, you're going to understand what I'm going to draw. Oops, sorry. Okay, so we have here an interval A, B, and I have a function. So f of A and f of B is the same. And the function is continuous, differentiable, and f of A equals f of B. So guaranteed that there's going to be a place where the slope of the tangent is 0. You understand? Okay. So of course, it needs to be continuous, or else, of course, I could have a jump and nobody guarantees that I'm going to have a place where the slope is 0. Also, it needs to be differentiable, or else I could definitely have something like this. As you see, the only place where it switches, there is no derivative, right? It's a point. It's a cusp. It's called a cusp. We'll do this later. And f of A equals f of B is the other requirement. Any questions?
Sorry, how do you know if the function is differentiable?
Okay, so if the function is like if I give you an actual function, how do you know if it's differentiable? You're saying?
Yeah, so how do we know like that it fits the criteria
Okay.
of?
It's a good question. Okay, we didn't do it yet. We're gonna do it when we do curve sketching, and we'll see where is the function not differentiable. And exactly, you're gonna see it's gonna be basically finding if the derivative is continuous. Basically, okay, we're gonna find f prime and see where it's not continuous, and that's where it won't be differentiable. Okay, we'll talk about this. Okay, good. So let's prove it. Okay, so there's three cases in the proof. Okay, so the first case, if f of x is constant, so it's equal to k, a constant. Okay. Okay, so A, B, as you see, f of A equals f of B, same height. And it's constant, it doesn't move. So obviously, okay, in this case, every value between A and B, every value C here, has a tangent, which is the line itself, which has a slope of 0. So the theorem works. Guaranteed for every C. Questions? Okay. Second case. Okay, so if f of x is a constant function, there's no problem, the theorem works. Obviously, it's always constant. Every value C between A and B has a slope of 0, tangent. Second case, okay, is if f of x is greater than f of A, okay, for some value x in AB. Let's draw. Okay, so the function goes like this. They're telling me, well, this is A to B. Okay, so my hypothesis tells me that I have a certain value x where the function is worth more than f of a. It's bigger. Okay, so since I'll write this here now. Okay, so since f is continuous on AB, then by the extreme value theorem, which we showed a few classes ago, f reaches a maximum value. Okay, we know that it reaches a maximum value. And also, since f is differentiable, so the derivative exists, then on AB, then by Fermat's theorem, which we wrote the other day also, f prime of C is equal to 0. Okay, where f of C is the maximum. Okay, so I'm sure it sounds very complicated when you hear it like this. Okay, so I'm going to let you finish writing and I'm going to re-explain. Okay, so again, f of A equals f of B. Good. Then we took the hypothesis, imagine that for some value between A and B, there is a value x where the function is bigger than f of A. So it's a bit bigger. Okay, so according to the extreme value theorem, a function that is continuous on a closed interval reaches a maximum value for sure. Okay, now, and according to Fermat's theorem, at every places where the function has a maximum or a minimum, okay, if the function is differentiable, which is our case, the derivative at that point is 0. So that guarantees, since it's continuous, it reaches a maximum. It's differentiable, the derivative at that maximum is 0. So for sure, if f of A equals f of B, there is a place where the slope is 0. And so that's what Rolle's theorem says.
What if it's a downwards parabola?
Very good.
A, B aren't equal, but it's a minimum.
Very good. So I would do a third case if there is an x where f of x is smaller than f of A.
Okay.
And I would do the exact same thing. Okay, so I'll write it here. It's a very good question. So if f of x is smaller than f of A for some value x in AB. okay, then I'm not going to do it. Then the exact same argument. And that completes the proof. That's all there is. Okay. So this is Rolle's theorem. What you have to remember from this is that a function, if it's continuous and differentiable, so continuous means there's no jump, no holes, and differentiable means it's nice and smooth, there's no pointy part, and f of a is f of b, for sure there's at least one place where the slope is 0. Okay. So this was Rolle's theorem. Any questions? Okay. Let's go to the mean value theorem right away. Let me write it down. Okay, so I showed you Rolle's theorem before because we're going to need Rolle's theorem to show the mean value theorem. So we should be convinced, okay, of Rolle's theorem now. If you're not convinced, let me know before we move on to this one. If you want me to repeat it again, the idea, the logic, anybody? Okay, good. So let again f be a function such that two things now. One, f is continuous on AB, and two, f is differentiable on AB open. Okay, so now there's no requirement that f of A equals f of B. Okay, then there is a number C in interval AB such that so f prime of C, okay, so in Rolle's theorem it was 0. Here it would be f of B minus f of A over B minus A. You're going to see that it makes a lot of sense once I draw it. Okay, so what does it say? Let's have a function like this. Let's say. Of course, this is f of b. And this is f of a. So what this says is that if you take the slope here, there is definitely a point, a value c, where the slope of the tangent is exactly the same. Okay, so the slope here is f prime of c. And of course, the slope here, well, it's a line, so y2 minus y1 over x2 minus x1. So this would be f of b minus f of a over b minus a. Any question?
Sir,
Yep.
so the f prime of c and fb minus fa, they're parallel?
Yep. F prime of c is the slope. You mean the red line and the blue line? That, yes, they're parallel.
Okay.
Yeah, exactly. Okay, so what the theorem tells me is that a f of a, b f of b, you draw a line connecting them. Well, the function, if it is differentiable and continuous, well, they're for sure going to be a value c where the tangent is exactly parallel to that line. Okay, makes sense? Okay, in other words, okay, if I explain it into, forget math in just life, if you take your car and you start driving from rest and you accelerate until 100 kilometers per hour, okay, well, the average speed, okay, let's say your average speed, because I don't know how you accelerated or anything, but your average speed, for sure there's going to be a place in your a time where you're going to have this exact speed. You at one point you will have the average speed, guaranteed. That's what it says. Okay, this is an average speed. There is even if you accelerate and you slow down, well, there's one point where guaranteed you will have the same speed as the average speed. Okay, anyways, we'll do examples soon. Okay, so let's just, before I prove it, okay, I'm going to give you maybe an example, okay, on how this works, and then we'll prove it. Let me find a good example. Okay, so example. let f of x is equal to x3 minus x, okay, on interval 0, 2. Okay, so find the value, okay, or values, they could be more than one, for which that satisfy, let's say, the mean value theorem, okay? Okay, so how does it work? F prime of x is what? So let's find f prime of x. 3x2 minus 1. Okay, then we need f of 2 and f of 0. Okay, so f of 2, I'm just going to move up a bit. Okay, f of 2, so I plug in 2 here, so I get 8 minus 2 is 6. And f of 0 is 0. Okay, and so now I need f prime of c is equal to f of b minus f of a over b minus a. Therefore, f prime of c is 3c2 minus 1. F of b minus f of a, 6 minus 0 over b minus a, 2 minus 0. Okay, so 3c2 minus 1 equals 3. 3c2 equals 4. So c is plus or minus 2 over root 3. So these are the two values that would satisfy the mean value theorem. But of course, you cannot take the minus 2 over 3 because it doesn't fit in the 0, 2 interval. So c will be 2 over root 3. Let's try to illustrate this with a graph. Okay, so I don't know what my graph looks like, but I know for sure that at 0, it's worth 0, and at 2, it's worth 6. Okay, so my guess is going to be something like this. Is it? I don't think so. Yeah, I messed it up. Whatever. It's not that important, okay, what it looks like. But here I have 2, 6. Here I have 0, 0. So it tells me that if I do at the value 2 over root 3, the slope will be exactly, okay, I didn't draw it correctly. I want to redraw it.
Sir, could you lower your page a little bit, please?
Like this. 1 second. Like this.
Thank you.
I'm just going to make it a bit more realistic. There you go. Okay, so these two should be parallel. At 2 over root 3, this is when the tangent is exactly parallel to the sort of secant. Okay, do you understand mean value theorem? Okay. So let's prove it now.
Sir?
Yeah.
So when C is equal to 2 divided by square root of 3, the slope is 3?
The what D
The slope.
is 3. Yeah, exactly.
Okay.
Exactly. Okay, which is sort of the average slope. So if some of you are doing physics now, if you do mechanics, so you know that if this is a position time graph, if this was a position time graph, well, this slope would be the average velocity between 0 and 2 seconds. Okay, I'm sure you've done this, and this would be right. Where's my pencil? And this here, the slope of this line would be the instantaneous velocity at 2 over root 3. Okay, if you've done this, okay? So that's what I was saying before. There is for sure a time between 0 and 2 where the instantaneous velocity is exactly equal to the average velocity. For sure, guaranteed. That's what the mean value theorem tells me. Okay? Okay, let's prove the mean value theorem now. So proof. Okay. So remember what we want to prove, that if f continuous on AB, f differentiable on AB, then there exists, let me show you this symbol, there exists C in AB. Have you ever seen this symbol before? Anybody? No? Yes? Okay, some of you haven't. Okay, so this means there exists okay, so there exists a C in AB such that f prime of C is equal to f of B minus f of A over B minus A. Okay, that's what we want to prove. Okay, so let's go. So this is what I'm going to do. I'm going to let g of x, I'm going to create a new function, g of x equals to f of x minus f of A minus f of B minus f of A over B minus A times x minus A.
Did you choose that randomly?
Sorry?
Did you choose that randomly?
No, not randomly. Okay. It's sort of a difference between two functions here, but let's not go. Could I? It's not random. I'm gonna explain you where I got it from in a minute. Okay. Okay. So you'll see that it's a difference between two functions, and you will see. Okay. Let me just continue, and you'll see where I'm getting with this. Okay, so let's check what's going on. What's G? Let's analyze G. Okay, so G, remember, is a function just of X. Okay, A, B are given to me. So f of A is a number, this is a number, everything's a number besides for X. So G is a function of X. So first thing, let's see what G of A is what. G of A is equal to, well, f of A minus f of A is 0. So I'm going to write this down. So it's f of A minus f of A minus f of B minus f of A over B minus A times, and this is A minus A. And so I get 0. Good? So G of A is, sorry?
Why would you get 0?
Why do I get 0?
Yeah.
Plug in f of A minus f of A is 0. Here, A minus A will be 0. So all this will be 0, 0, everything 0. Everything cancels. Good?
Yeah.
Then G of B is what? G of B is, so f of B minus f of A minus f of B minus f of A over B minus A times x minus A, so B minus A. Okay, so what will happen here? These will cross out, and you'll have f of B minus f of A minus f of B minus f of A. You'll have 0 again. Okay, so that's very good. At G, my function G has the property that at G of A is the same thing as G of B. They're both 0. Okay, also G. So questions until here, do you have questions? Okay, other than, of course, where did I come up with this? That's a valid question. I'm going to explain you in a second. Okay. Now, G is continuous. No problem with that, because, so I'm just going to box G so that we can refer to it easily. Okay, so that's my function G. Okay, so G is continuous, obviously, because there's no restriction, no denominator of 0. F is continuous, there's no problem. So I'm minusing continuous functions, I'm going to get a continuous function, no problem. And also, okay, so on interval AB, no problem. And G is differentiable on AB, okay? Because if I do the derivative of this, I'll get this number plus f prime, which is, everything works here. So there's no problem because f is differentiable.
Sir,
Yep.
could you just like repeat why G of B is equal to 0?
Why G of B is 0? This?
Yeah. Mm-hmm.
Okay. Yeah, so maybe I'm going a bit too fast if you're still here. Okay, so why is G of B 0? So do you understand how I found this expression?
Yeah.
Sure? Or
Yeah.
not? Okay, I just replaced in here, I replaced the x by b, x by b, x by b. That's it. Okay, now b minus a over b minus a, cross them out. And so I'm left with f of b minus f of a minus f of b plus f of a. And everything will cancel.
Okay, I got it. Thank you.
Okay, good. Okay, please stop me because you guys are not stopping me, so I keep going. Okay, so stop me. I don't mind repeating everything from here if you're stuck.
Could you do it, please? Repeat everything from the beginning. I'm not quite sure I get it.
Okay, perfect.
Thank you.
From here?
Yes, from there, please.
Okay, no problem. You understand what we're trying to prove, right? Or is this complicated? I know it's much more complicated than what we've been doing so far because it's less technical, right? It's more, we have to think a bit here. Okay, so again, I want to show that if you take any function f that is continuous over an interval ab and differentiable over that interval, then there for sure is a value c in that interval for which f prime of c is equal to the slope of between f of a, f of b, ab. Okay, this. Okay, so this is what I want to show. I want to show exactly this here. Okay, that there is a value c for which the tangent has the same slope as this blue line. Is that okay? What we want to show?
Yes, again.
Okay, so let's go. So to do this, I did sort of a twisted way, and I created a new function which I call g. And this is how I create it. It looks very complicated, but if you understand where it's from, you're going to see it's easy. Okay, so it's f of x minus f of a minus f of b minus f of a over b minus a times x minus a. This is my new function.
Where does it come from?
I'm going to show you. Okay.
Okay.
Somebody asked already a question. Where is it from? I'm going to show you. Okay. But for now, imagine this function. This is a new function g. And I want to understand what's going on with this function. So the first thing I notice is that if you plug in a in here, if you do g of a, you'll get 0. And then if you plug in g of b, you also get 0. If you plug in b and g. Okay? Do you want me to show you how I found 0 here? Or is it okay?
I understand that, but
Okay, that's it. So I just created a function g, and I noticed that it's continuous, no problem. I noticed that it's differentiable, no problem. I noticed that g of a and g of b are both 0. These are just things I noticed, and that's why, of course, I created this function because I wanted to have this here. Okay?
Sure.
Yeah?
How did you know that it was continuous?
How do I know that? I'm sorry?
How did you know that it was continuous?
It's continuous because it's a continuous function minus a number, so it's continuous, minus a number times, this is a continuous function, x minus a is continuous, so everything is continuous here. There's no, if I were to divide by x, okay, if there was a square root suddenly, or a log, or then there would be a problem. But there's nothing, it's a continuous function plus a polynomial, simple one. Okay, so you don't need to really justify this. Just be able to recognize that it's continuous. Okay? Should I continue? Any other questions?
yes.
Yeah.
But why are we doing g of a and g of b? Like, what are we trying to prove?
I'll show you. Yeah, good. You're asking me where are you going with this?
Yes.
Okay, good. So look carefully. Since g of a is equal to g of b, and g is continuous, and g is differentiable, then we could apply now Rolle's theorem. Okay, I'm going to remind you Rolle's theorem.
Oh, okay.
Okay, so Rolle's theorem was saying that if it is continuous, differentiable, and if f of a is equal to f of b, which is the same we have now, g of a is equal to g of b, then we could say that there is a value c for which f prime is equal to 0. Good? So I'm going to write down here. We can now use Rolle's theorem. Okay, and therefore, there exists a value C in AB such that what? Can you tell me?
F
F prime of C is 0.
No, we're talking about G here. So G prime.
Oh, sorry, G.
Yeah, so G
Yeah.
prime of C is equal to 0. All good? So guaranteed now G prime of C I showed with this function, sure that G prime of C is 0. Questions? Okay, so let's find G prime. What is G prime of X? That's G of X, right? So G prime of X will be the derivative of this, which is F prime. What's the derivative of this? F prime of A? What is it? I need an answer. What's the derivative of F of A?
0.
Very good, thank you. Okay, so it's 0. Don't tell me F prime of A because F of A is a number. And the derivative of a number is 0. So it's F prime. Then the derivative of this here, what will it be?
Zero, 2.
No, there's an X here.
It's going to be the entire fraction.
It's going to be the entire fraction, exactly. So it's going to be minus, so if I FOIL the fraction inside here, I'm going to get minus F of B minus F of A over B minus A. That's what I have as a derivative. So this is G prime of X. Would you like me to repeat how I got this derivative?
Yes. Yes.
Okay, so let me just go here. G of X. Just I want to leave some space to show you where I got this function from. Let me see. I think I could do it here. So G of X is equal to F of X minus F of A. Well, I'm just going to move up a bit, sorry. So F of X minus F of A minus, and I want to multiply everything inside. So I could have minus, so F of B minus F of A over B minus A times X, and then plus F of B minus F of A over B, sorry, B minus A times A. Do you understand that this is the same as what we have up here? Oh, I'm sorry, I can't see both. But what I did basically, I did this times X and then this times minus A. Okay, and I got this here. Is this okay for you?
Yeah.
Anybody not clear with this? Okay, I didn't derive yet. I just multiplied the big fraction by the two terms. Okay, no questions. So now I'm going to do the derivative. So G prime of X. So this will become 0. So I just have F prime of X. So 0. This also will be 0. It's a number. These two disappear. And this, how do you find the derivative of a number times X? It's just a number. Is that okay? Anybody? Questions?
Yes.
Good. Anybody still have a question on this? I don't mind repeating again. Okay. So I found G prime of X is this, and it tells me that there is a value C for which G prime of C is 0. So therefore, F prime of C minus F of B minus F of A over B minus A equals 0. And therefore, F prime of C equals, if I send this on the right side, F of B minus F of A over B minus A. And that's what I wanted to prove. Okay, I just showed that there exists a C, such that this is true, which leads me to this is true. And that's the mean value theorem. Any questions?
Yeah, sir, I have a question.
Yep, go ahead.
You know that complicated like function that you like came up with? Yeah, How are we supposed to think of something like this during the exam? Like, how are we supposed to be like, oh, let's write something like this?
It won't happen.
Oh, okay.
It won't happen. If you go into mathematics, you have to come up with stuff like this, but not in calculus 1. Okay.
Thank you.
But did you understand what I did?
Yeah.
Okay, other than just coming up with this, of course. Okay. So where did I come up with this? Well, I didn't. It's a classic proof. It's actually like this. So I'm going to try to fit it here and not write too small. Okay, so this point here is A f of A. This point here is B f of B. And this curve here is f of x. Okay, so what I'm doing is I'm finding the difference here. G is this function here that gives me the difference. This is g of x. Okay, g of x gives me the difference between f of x and this line. Okay, so of course at A, f of A is equal to f of A, so it's 0. And at B also, f of B is equal to f of B, so it's 0. The difference, right? The difference here is 0, and the difference here is 0. This is why we had, right, 0 here and there, if you remember. Okay, and so that's the only thing I did. What I did is g of x is f of x minus, I would find the equation of this line here. And the equation of this line is y equals ax plus b, which is right here. Okay, so this would be the equation of the line. If you work it, y equals ax plus b, you'll get to this. So f of x minus the equation of the line, that's g of x. Okay, that's what I did here for g of x. That's it. Okay, is it clear? You should do it as an exercise if you want to find the equation of this, and you will see that you'll get what I have up there.
Sir?
Yep.
Sorry, did the f of b minus f of a over b minus a become f of b minus f of c? Or is that just an a?
Oh, no, it's an A. Where? Here?
Yeah.
No, it's an A.
Oh, okay, thank you.
Okay, any questions? No? Okay, that's it for the theorems. Okay, so what I should do now, I think it would be wise, is I'm going to take one paper and I'm going to write down all the theorems. Okay, so sort of a summary of all 4 theorems, and that would be great that you have them in one paper. Okay, so let me just rewrite them. You done writing? All right, so let's do a little summary. Okay, so the first thing we had was the extreme value theorem. So extreme value theorem. It said that what? if f continuous on interval AB, then f reaches maximum and minimum values. Okay, then Fermat's theorem.
So I have a question
Yeah, go ahead.
about the extreme value theorem.
Yeah.
What if like the function is like a constant in A and B?
Okay, good question. What about it?
So there is not, it's still continuous, but it's not gonna reach a maximum and a minimum because it's all the same.
Yeah, all the same value is all the maximum, all the minimum.
So the maximum and the minimum will be the same value?
Yeah, of course.
Oh, okay.
No problem. Could happen. Okay, you're good. Fermat's theorem. So Fermat's theorem is the same thing, except that if it is differentiable also. Okay. So f continuous on AB and f differentiable on AB, then if f has a maximum or minimum at C, then f prime of C is 0.
Sir, why is it that every time we say f is differentiable, we never include a and b in the interval?
Because to be differentiable, okay, you have to be smooth. It has to be smooth from both sides. If you just end up, if your function ends up like this, okay, let's say like this. Well, nothing exists here and nothing exists there. So I don't know if this is going to go after that, if it's going to go like this or if it's going to go like this. You understand? So I don't know if it's really a pointy part or if it's a smooth part. If you want to determine the smoothness of a function, it needs to be, you need to have something after that point. Well, if the interval is closed, if it was closed here, then I'm abruptly cutting it and I don't know what's going on after. Do you understand?
Yes, thank you.
Okay. It's a good question. You're right. Okay, so it's okay with these two. So extreme value theorem, Fermat theorem. Let's go with the intermediate value theorem. Okay, which I think is the most tricky one. Okay. So again, f continuous on AB. So let n be any number between f of A and f of B. Okay, f of A different than f of B. Then there exists a value C in AB such that f of C equals n. Okay, last two theorems that we did today, Rolle's and mean value theorem. So Rolle's theorem. So if f is continuous on AB, f differentiable on AB, and f of A equals f of B, then there exists a C in AB such that f prime of C is equal to 0. Okay, and the last one, mean value theorem. If f is continuous on AB and f differentiable on AB, then there exists a C in AB such that f prime of C is equal to the average value, right? FB minus FA, the average slope. That's it. That's the mean value theorem. That's all the theorems we're going to do. The last one we're going to do is L'Hopital's rule. Okay, so basically we proved pretty much well, these two. We didn't prove the IVT and the EVT because they require some more advanced stuff, okay, which is not in this course.